Okie doke, let's jump in to take a look at an example. So here's a circuit, couple of sources, and we want to find the current through the 8 ohm load resistor. So that's the question: is what's IL? The current delivered to the load. And we're going to do this using source transformation. So as we go through, I'm going to leave the load. I'm going to leave the load alone. So what we're going to do here, just follow along. I'm going to take the load. This circuit right here between these 2 points, I'm going to call those 2 points maybe A and B or something like that. And what I'm going to do is we're going to reduce the circuit as seen by the load. So each step of the way through, I'm just going to draw the load like this, okay? And we'll leave it in purple. And then we'll keep reducing the circuit to the left-hand side of that dashed line until it's super easy to solve. In fact, we'll get it to a point where it's just one single loop, and it'll be really easy to find the values. So now we're going to continue to start to transform this thing. So let's go for it. First thing I'm going to do is, look at this. There's a voltage source in series with a resistor. Let's transform that. So I'm going to transform that into a current source in parallel with a resistor. Okay, the resistor's value was 4 ohms. So that's straightforward to do. There's a 4 ohm resistor right there. And the value of the current source, remember this is going to be, this value here is going to be IS would be, remember it's VS divided by R, right? So that's 5 volts divided by 4 ohms is 1.25 amps. So this is 1.25 amps. All right, we'll leave that drawn in red so we can keep track of which parts of the circuit we've transformed and which parts we have not. So the parts that we have not, I'll just draw this still in black. Okay, there's the 6 ohm resistor, and then here is the 2 amp source, and then here this is connected to our load. Looks like my load got load resistor is a little bit lower there. Okay, so there we go. All right. All right, everybody good with that so far? We've just transformed the 5 volt and 4 ohm resistor into, that were in series, into a 1.25 amp current source in parallel with a 4 ohm resistor. And we've left it connected to the 6 ohm and the 2 amp source accordingly. All right, so what we're going to do now is I'm going to propose that at this point, let's take these resistors. Let's take this current source here and this 2 amp current source. Notice that both of those are pushing current into the top node. So we can actually sum those together. So I'm going to kind of come up this way here. I'm going to sum those two together into a single current source that is equal to the sum of them. That would be 3.25 amps. And then notice that these two resistors are in parallel, the 4 and the 6. So I'm actually going to put those together. So this is 4 parallel 6. And then we're going to connect that to our load, which we'll continue to draw in purple. Keep in mind that, you know, since it's the load we're looking for, here's RL, or it's the current through the load we're looking for, we're going to make sure to not wrap that up into the circuit. So, you know, yes, the 4 ohm and the 6 ohm are also in parallel with RL. So at this point, I could turn it into you know, one single resistor, we could put all of them together in parallel, 4 parallel 6 parallel RL. I don't want to do that because I still want to find the current through RL. We still want to find that. So we're not going to wrap that into and combine it into a parallel resistance with the 4 and the 6. We're going to leave it off to the side. As a what if, like what if we wanted to know the voltage across all of those? Well, the voltage across the 4 parallel 6 parallel RL is all the same because they're all in parallel. And if that was what we were looking for, then it'd be fine to wrap it in parallel with the 4 and the 6. And then it'd just be 3.25 amps running through that whole parallel combination. Whatever the current times that equivalent resistance is would be the voltage, and you'd be done. However, we've not been asked to find the voltage across the load. We've been asked to find the current through it. So we're going to leave that load resistance off to the side. I hope drawing these in colors and kind of trying to keep things separate is helping you see how to organize your notes and the sub-circuits you continue to draw as you're solving your own work. So let's take a look at that resistor, this 4 parallel 6. I'll just throw that in here real quick. This is 4 parallel 6. That's 4 times 6, which is 24, divided by 4 plus 6, which is 10. So 24 over 10 is 2.4 ohms, right? So that's the 4 parallel 6. Hey, how about that? Now we have, take a look, we've got a current source, that 3.25 amps, in parallel with a, let's see, I'll do this in another color. We'll do this in burgundy here. We've got this 3.25 amps. If we just kind of do a dashed line around this one here, in parallel with that 2.4 ohm resistor. So let's transform it again. So we want to turn it into a voltage source. We know we can turn it into a voltage source. I'll just draw that down here. It'll be some value, a voltage source of some value. In this case, it's going to be in series with a, what is it? It's going to be a 2.4 ohm resistor. And then that is still connected to RL, the load resistance. Okay, which is 8 ohms. All right, so now all we need to do is find the value of that voltage source, and we know how to do that pretty easily. Vs is equal to Is times R, which is, in this case, it's 3.25 amps times the 2.4 ohm resistor, which is 7.8 volts. Let me try to give myself a little bit more room. 7.8 volts. Okay, so this is 7.8 volts here. Okay, now we've been asked to find IL. And so that's straightforward enough. IL is just that 7.8 volts divided by, in this case, it's 2.4 ohms plus RL, right? The voltage divided by the total resistance, or in this case, it's 8 ohms, which would be 0.75 amps. So here's the answer, right? There's the answer to the load current. If we had been asked to find the voltage delivered to the load, the voltage across the load, that would be easy enough to find as well. That would be 7.8 volts times, well, in this case, it'd be times RL over 2.4 plus RL, or 8 ohm over 2.4 plus an 8 ohm, which would be 6 volts.